Hello, everyone. How are we doing? Good still? Great. So the next 50 minutes we are going to spend on talking about smart analytics. If you heard the keynote earlier today, we highlighted few of the key capabilities that we announced at the show. But we want to take you through a few more details about a couple of customer examples. We also want to show you some cool demos of things we did not highlight in the keynote earlier today. So if you really think about it, first thing before that, your feedback is really important to us, so please take time to go ahead and provide the feedback. Enables us to improve the content for next time. The feedback form will be available after 20 minutes of session starting, so while I'm talking, if you get bored, you're absolutely OK to go ahead and give feedback, but always give 5 stars, OK? So if you really think about it, you heard from a lot of customers even yesterday how organizations are digitally transforming themselves using Google Cloud. But one of the things I'm super excited about is how organizations are reimagining their whole industries and how things are moving. Like from self-driving cars and how massive amounts of data is being collected for driving cars now and driven through the cloud. But more importantly, even the traditional industries, for Ocado, which is the grocery retail organization out of UK, how they are collecting massive amounts of data, understanding their whole supply chain, what product is going where, how much time does it take, and not just leveraging it to improve their own organization, but also sharing some of those metrics with their partners so that they can improve their organization, their supply chain and all. Another great example of this is just gaming. If you think about King, which is one of our like users of Google Cloud, they're collecting billions of events. They have 200+ games that they have, mobile games. They collect all these events that are coming from the various games, trying to provide much better customer experience, in-game experiences built on top of these massive amounts of data sets. And we see this across multiple gaming organizations across the globe where real-time events are being used to provide much better customer experience. Another example is just traditional media organizations. Across the globe, the Daily Telegraph in UK, but we have similar examples with Hearst in US, various different organizations across the globe, trying to reimagine what the industry looks like, taking the information about what customers want to go ahead and listen, what kind of articles they're interested in, how do you get new subscribers on the digital platforms, digitizing all the content and all. So super exciting to see how the industries are changing and how industries are reimagining themselves. If you look at our just momentum of Google Cloud, especially around analytics, you'll see we have organizations across various different industry verticals, from retail, healthcare, financial services, media entertainment, gaming, energy, automotive, transportation. Across the globe, we are seeing tremendous momentum for the smart analytics platform on Google Cloud. And it's also interesting to see the kinds of scenarios that people are using. We'll talk more about a couple of them later, but we're not just limited to like just BI and reporting kind of scenarios. Organizations are using their data to innovate, to build different kind of customer experiences, and do really large-scale analysis on top of their data. So what are we trying to focus on at Google Cloud? Our vision is very simple. We want to create a radically simple-to-use, intelligent data platform that provides actionable insights in real time for organizations to drive digital transformations with a lot of focus on large enterprises. What does that mean? The key things that I try to highlight is it has to be simple, it has to be intelligent, it has to be actionable, it has to be in real time, and you have to focus on enterprises. So if you look at that and look at our strategy of investments, so as part of my role, I'm responsible for where we invest, what kind of capabilities we are building. So if you think about it, it's one, being enterprise ready. What do I mean by that? Focusing on scale, reliability, and security, making sure that that's the fundamental thing that we are focused on across the whole platform. The second is ease of use. We want it really easy for organizations to derive insights from from the data that they collected. It's not just important to break the data silos, bring it into cloud, but also it should be very simple to go ahead and access that information, get value out of it. This is where our big investments around big sheets or connected sheets comes in, so that you can derive insights and share it across your whole organization. The next thing is making it real-time and intelligent. This is one area around Bigquery Ml, real-time collection. Like as Thomas mentioned, we have improved our ability for you to go ahead and ingest data into Bigquery by just 10x. You can get millions of events per second in real time and then analyze on top of it. So a lot of innovation happening in that space. And finally, and most importantly, we are big believers in open source and multi-cloud environments. So we have been investing a lot in that space, making sure that you have all the open source tools and capabilities you need in the platform for analysis. You saw this slide, a version of this slide earlier today in the keynote, but the key capabilities that we are trying to provide with the whole platform is, of course, one, ability to collect data in streaming and batch form at scale, process it with open source technologies using Dataproc, or with our cloud native capabilities that are there, making it super easy to go ahead and build ETL pipelines with data fusion. Or if you want to do data wrangling as a data analyst, you can do that with cloud data prep. You can then store your data, structured, unstructured, on Google Cloud Storage for a data lake, or BigQuery for a data warehousing scenarios, and then use the SQL engine that we have with BigQuery, or use a Dataproc, which provides you different kinds of engines from open source, like Spark, Flink, and all of that, to run those algorithms. And then finally, you can understand your data with Cloud AI, as well as various BI partners. And then more importantly, underneath it, we are providing data catalog capability, where we will automatically identify all the data sets that you have, catalog it so that you can discover content that you need for various different scenarios. And we have workflow orchestration with Composer, which allows you to stitch various scenarios together on top of the whole platform. So that's the whole end-to-end platform capabilities that we are providing with our smart analytics capability. As I mentioned, we have launched more than 50 key capabilities just in 2019. This is just a subset of that that we have. But now what I want to talk about is focus on a key theme we have been noticing across the industry. And the theme is around convergence. If you think about it, there are 3 or 4 key areas where we are seeing a lot of conversion. First of all, data lakes, data warehouses. These concepts that were there in organizations are coming together, and organizations want to think about a fluid system that allows you to go ahead and analyze data at scale and not worry about what a data warehouse is, what a data lake is, but want to have an environment where both of them can coexist. So that's one. Stream and batch processing. We are seeing like convergence across all of these systems. Hybrid multi-cloud environments, how they can coexist. And then finally, analytics, AI, ML. Organizations used to have another silos where you had analysts, which were like data people that understood data really well, could analyze any data. And then you had like PhD data scientists within organizations. They were siloed in their world to go ahead and create like complex machine learning models. We are seeing convergence across that whole frame, where we are seeing with newer innovations, ease of use, different folks are doing playing different parts within that organization. Let's talk about data lake and data warehousing. Traditionally, data warehouses have been used to better understand your business, right? You can do reporting, you can do dashboarding, you can do basic analysis, you have standard metrics to measure your business and all. The challenge was you could never scale with the data warehouse with massive amounts of data that you had, so you aggregated, you summarized, but allowed you to better understand your business. With data lakes, you could explore your business. You wanted to get all the data within a data lake, and you could use it for different kind of exploration. You could go ahead and analyze data at scale in them and leverage it for that. You could have structured, unstructured, semi-structured data in it. What we are seeing is a convergence across all of them. One of the challenges of having the old model of the data lakes and data warehouses was it was always the compute and storage was linked together. One of the big challenges on data lakes actually is, as the size of data grows within it, you're paying the price of compute for the growth in storage because they're all coupled together within the same environment. Where we are planning to go is a very different approach. So if you think about it, what we are trying to do is you can go ahead and decide to store your data either in a data warehouse, which is a structured data store with BigQuery, or in your data lake with GCS. It doesn't matter. You can leverage the same set of engines or similar set of engines, whether it is a MapReduce, Spark engine, Beam, Flink, Spark, or BigQuery SQL across all the data that you have across different environments that you're storing. So you could store data, your Parquet and ORC files in Google Cloud Storage, and use BigQuery SQL to go ahead and analyze it, or you can store it in BigQuery and leverage Spark code to go ahead and analyze that side of the environment. So completely fluid environment is what we are looking at. And if you think about BigQuery, BigQuery is our highly scalable cloud data warehousing solution. It can handle petabytes and petabytes of data. We have our customers who have like tens to hundreds of petabytes of data within BigQuery, and we have other customers who are building smaller data marts with few terabytes within an organization. We have a spectrum of companies. We have organizations that are actually publishing billions of events every day within BigQuery in real time, and then using that for real-time analytics and getting value out of it. And then we, as part of BigQuery, we also have embedded machine learning. With just 2 lines of SQL, you can create machine learning models and start using them. So you can do better segmentation, you can do better regression, you can do a linear regression, logistical regression, you can do matrix factorization, clustering, and we also are adding different capabilities in that space. So if you look at that, the main thing in 2019 that we have focused on is this interoperability of data lakes. So there are, as I was mentioning, there are 2 key capabilities. With BigQuery now, you can fire a federated query on your data in data lake in GCS, and then you can use any of the engines on top of BigQuery to go ahead and analyze that. With that, let me actually invite James Malone to the stage to share more about our new capabilities in open source, as well as show us a demo.
Thanks, Sudhir. Thanks, I appreciate it. It's nice to be here. So I'm James. I'm a product manager in data analytics. And what I want to do is I'm going to show you a demo in just a minute to showcase how we're trying to move managed open source forward. But quickly, I want to explain why this is really important. Google has great infrastructure. And open source projects are essentially the amalgamation of thousands and tens of thousands and hundreds of thousands of needs. And we think there's real power in joining the two together and managed services that solve problems for you. Here you see the logos of 2 of our managed open source services, Cloud Dataproc, which runs the Spark and Hadoop and Friends like Presto ecosystem, and Cloud Composer. And we really want to lower the bar of running the managed open source so you can use the open source tools without having to be an expert on standing them up and tuning them and trying to debug them and figure them out. I mentioned moving open source forward. The Spark and Hadoop ecosystem has been somewhat stagnant for a while. There's a general interest in moving to Kubernetes. Recently, we announced that Cloud Dataproc supports running Spark on Kubernetes clusters that are managed by Dataproc. This gives you a unified control plane to run open source workloads, in this case Spark and Flink soon, without having to think about Yarn or Kubernetes. And that's exactly the demo that I'm going to show you. Sudhir also mentioned interoperability. I'm going to show you a really cool feature of Dataproc and BigQuery that hits at how we've tried to make open source interoperable as well. So with that, I'm going to go ahead and show you my demo. Perfect. OK. So here we see Cloud Dataproc. This is the Google Cloud Console. Here I have a production cluster that I've set up. This is a traditional Hadoop Yarn cluster. So if you've used Spark and Hadoop, you'll sort of understand this is a traditional Hadoop cluster here. It has 20 nodes. I created this right before the demonstration started. You'll actually see I over-provisioned this cluster, and we have the autoscaler turned on. And the autoscaler realized nothing was going on and intelligently scaled my cluster down to try and save me money, because there's no sense in running more than I have to. I also have a Kubernetes engine cluster here. And maybe an IT admin or somebody created this cluster and they want multiple groups to share this cluster to better utilize resources. But as you see, this cluster wasn't part of Cloud Dataproc. So what I'm going to walk you through is how we actually attach this cluster to Cloud Dataproc and make it a Spark and Hadoop cluster as well. The first thing that I'm going to do, though, is show you exactly how we do that. So the way that we attach this cluster to Cloud Dataproc is we run a Helm install. And if you're familiar with Kubernetes, you're probably somewhat familiar with Helm, the package manager for Kubernetes. There's just a few options here that I've set. You can see that I've shaded my, my whitelisting token. If you want to join our alpha, there's an email that you can just email us at. We're happy to invite anybody to our alpha that wants to join. While that's running, I'm going to go ahead and run a job on this Yarn cluster. I will explain what this job does after I go ahead and run the job. I'm just going to clone a pre-existing job because I think as much as you all want me to stand up here and type in front of you, it's not that exciting. We're going to go ahead and name the job and label it as Yarn so we know what's going on. And this job, if you're not familiar with Dataproc, Dataproc has an API for managing clusters and also jobs and workflows, so you don't have to be an expert and use SSH tunnels and all that crazy business. If I were you, I'd be wondering, what does this job do? And this is the feature that I wanted to show on how we've tried to create interoperability between cloud data products like Bigquery and open source. So this job tries to find the most popular subreddits in 2018 and 2019. But what's really cool about this job is we're doing it all in Spark data frames and reading directly from Bigquery storage. So you can see that we're creating a Spark data frame. We're specifying the Bigquery data sets that we want to read from, and they're split out by years. And then we're directly reading that data into a Spark data frame. We're not moving data around. We're not having to copy data. All of this is basically Spark native code, and it's directly reading from Bigquery. You don't have to really think about trying to duplicate data and copy data and shuffle data. We're then grouping that data and counting the number of posts by each subreddit, and the job finishes by enumerating all of the specific results. So if you're unfamiliar with this connector, it's a really interesting thing to be aware of because it allows you to seamlessly use Bigquery and Spark together quite well. You can also now see that two things actually happened here. One, the autoscaler has realized that there's more work going on the cluster, so it's actually started adding capacity to the original Yarn cluster, which is quite interesting. And it's actually started adding preemptible workers, so that's useful. But you can also see that the Kubernetes cluster here is now. And you don't think about Yarn or Kubernetes. We're not creating this split world. It's all seamlessly integrated together. To sort of show you an example of why this is really important, I can take this job that I ran on my Yarn cluster. I can simply clone it, give it a new name. And moving this workload from Yarn to Kubernetes is as simple as just changing the cluster and then submitting it. That's it. So you're not thinking about having to re-architect for Kubernetes. You're not having to think about what to do and how to shift. It's all very integrated and seamless. And we're bringing all of the features of Dataproc, the security, the logging, the integrations, to the Kubernetes world as seamlessly as possible. And finally, you can see that I have the results from querying Bigquery directly, and we can now ascertain which subreddits are the most popular. Thank you very much.
Thank you.
Yep.
I think the most important thing there, James showed you the autoscaler, which is key capability we went GA with. It's pretty amazing. It will automatically scale, make sure that it only uses capacity that you really need to. The other thing was ability to run Spark jobs directly on Bigquery data. We have a great customer story from for Two Sigma. They're actually a hedge fund out of New York. They collect massive amounts of data. They use machine learning with Spark ML to go ahead and run on top of Bigquery using our capabilities, and then make trading decisions and define trading strategies on top of all of that. I love SQL, but I know sometimes SQL can be limiting. Enabling Spark on top of Bigquery just opens up a completely different kinds of scenarios for organizations. With that, I want to invite Shane, who is CTO of Big Data at HSBC, to share their story, how they've thought about these.
Thank you, Sudhir.
Thanks, Shane.
So good afternoon, everyone. Really excited to be here. I'm Shane Lamont, and I have the privilege of being part of an awesome IT team who are helping to transform the way HSBC offers banking products to our customers. You may be familiar with the HSBC brand, but let me give you a few stats about the company. Nearly 4,000 offices, 40 million customers. We're present in 66 countries and territories, $53 billion in revenue, and we have over 230,000 employees. We were founded in 1865, and that's a long heritage. And to put 150 years into context, I'd like to show you something. It's a typewriter. And here's something else that has been around for 150 years, and while the technology has changed, that keyboard is entirely relevant today, and you might have one on your phone. And for HSBC, over 150 years, our technology has changed, but secure banking and offering great banking services to customers is still essential today. So, because we have lots of customers and we process $1.5 trillion in payments every day, we gather a lot of data. So if we're about to start a data and analytics project with a lot of data, that's a big decision. And because that decision can impact our employees, our customers, and our reputation, we want to make sure that we get it right. So what is a big decision in an analytics project? And Sudhir covered some of this, very well, I might add. But for us, a typical big decision is, do you want a data lake or a data warehouse? Very common. And the data lake is where we load lots of unstructured data. We want to understand it and explore it and see what insights are in it. Whereas a data warehouse is where, after we understand what it is, we want to structure it, explain it, and report it. And it's a big decision, and you might be making one of those decisions at the moment. You might have made it a few years ago, or you might be about to make it. So what does that decision look like if you're doing it on-premise or if you're doing it on cloud? So if you're making a big decision on-premise, that's like buying a nice, shiny new car. You're going to spend a lot of money. You have to decide what you want to do because you're making a choice, capacity or speed. And once you've made that decision and you've gone through all of that analysis, once you order it, you have to wait for it to be delivered, and then once you start using it, you're going to use it for a long time. That's what on-premise looks like. Now, if you're making that decision on cloud, you have a lot more options. That's more like going on holiday and renting a car. You want it for a specific purpose, for a short period of time, and you therefore will use it for a particular outcome that you want. You might want it for somewhere sunny, space, carrying things, or a convertible. And therefore, at the end of the short period of time, you return it. You get the outcome, you get the value, and if you start a new project or want to rent it again, you can make a different decision. That flexibility is really important. But nevertheless, it's still a decision. And you might be thinking, okay, Shane, what does HSBC do? Do you load and process your data in a data warehouse, or do you put it into a data lake? And my answer to that is, yes, we do. We use both because we need both, and cloud enables us to have both. So let's take a little look at an architecture on cloud through Google Cloud where it enables us to have both of these. You've probably seen lots of architecture diagrams like this, so let me walk you through this particular one. We acquire data, explore it, and report it. And the way we do that in HSBC is we have lots and lots of data sources, thousands, not a couple. And we move that data, first of all, securely and within all of the data processing regulations and laws, and we move that, first of all, to Google Cloud Storage through a product called Juniper X. Now, once you've got it in Google Cloud Storage, we have lots of choices. If we want to use MapReduce or Spark, because we've got some legacy code in there, we can have a data lake by spinning up Dataproc. But if we want to use some clever third-party libraries, or perhaps we've written them ourselves, we might process it through Compute Engine. And if we are fortunate enough to have a greenfield project, then we may use serverless with something like Dataflow or some of the other tools. Putting that information back into Google Cloud Storage once you've processed it means that it's then available to the Bigquery data warehouse. And once it's in the data warehouse, all your third-party tools and your analysts and everybody who wants to use that get all the benefits of that. So the great thing about this architecture is it's not theoretical. We're using this in HSBC today. And through the great work that we get through our cloud services team and our finance team, we use this architecture to reduce the reporting for liquidity risk down from over 10 hours to 30 minutes. And that's a really fantastic outcome if you have daily reporting with tight regulatory deadlines, because that gives us more time to deal with some of the issues that come up in any large, complex operational system. Now, Sudhir did say earlier that you can now run some of your Spark and Clever processing on the data that's in your data lake, and in your data warehouse. And the data warehouse can query some of the data that's in your lake. So now that I think about this, I might have misled you, and I possibly should apologize. It's not that cloud gives you both. It's that it gives you more than both. And that's really important for us because it keeps our options open, and we therefore can make those decisions time and time again, and the best decision that we want to make for us at that time. So to summarize, the business environment, especially in banking, is changing rapidly, and the rate of change is the fastest it has ever been and the slowest that it will ever be. So the ability to make decisions quickly and flexibly is really, really important. It's a competitive advantage for us. And Google Cloud enables us to focus less on the infrastructure and all the admin around the decision, and it enables us to focus more on the outcome. And for HSBC, that outcome is to make banking with HSBC simpler, better, and faster for our customers. And that, for us, is a great decision. OK, I'd like to pass back to Sudhir. Thank you very much for your time, and over to you.
Thanks, Shane. Thank you. So as Shane was saying, you don't have to make the choices. It's the convergence is allowing you to go ahead and pick any one of the technologies as you go. One of the big announcements that we have that we're launching this week that's coming is Bigquery Reservations. We understand with Bigquery, we have an on-demand model, which was like pretty popular with a lot of customers. A lot of organizations do want to have a consistent payment model where they basically get a predictable bill. And with Bigquery Reservations, we are providing two key capabilities. One, give you a flat billing model, which you can decide how much you want to spend on analytics, and then go ahead and reserve that. And that's the maximum bill you will get for Bigquery going forward. So that's one key capability. Second is your workload management. You do want to take whatever you want to spend on analytics and maybe decide by department you want to go ahead and split that spend, go ahead and give different amount of spend for marketing versus finance department versus a different team. You can do that. You can also make it based on workloads where you say, hey, the BI and reporting should get X amount of spend versus ETL jobs get Y. You can do those workload-based decision making. So super excited about that. This has been one of the big asks from our large enterprise customers. So this will give you predictability as well as flexibility in managing it. The second thing is it's all going to be available online. So to get more Bigquery capacity that you need, you can just go online and start leveraging the tooling now. That's one big thing. Here is an example of a Tco comparison that we have done. Actually, we haven't, like the ESG is, I think, the agency that did this, where you can see what is the total cost of ownership over a period of time with Bigquery versus all the different key cloud-based analytics solutions that you have. The next thing that I want to talk about is convergence of stream and batch processing. The streaming data is growing really fast across organizations, and we do want to go ahead and make sure that we are providing you with capability that allows you to not build one set of code that runs consistently for streaming as well as batch scenarios. We have a lot of customers where the similar kind of data may be coming from streaming, let's say with PubSub or Kafka, or it's coming on GCS as files, and they want to go ahead and do common processing. And with Beam, you can basically do that as a data flow as an engine or many of the other engines. One of the other things that we are focused on is not just bringing together stream and batch processing, but also providing you the consistent framework which allows you to go ahead and pick your choice of programming languages. You can use Java, Python, You can leverage Go. You can leverage SQL with Dataflow SQL now. And you can use, for execution, any one of the engines that comes with it. Like you can use Dataflow, of course, as a serverless product, but you can use Flink, you can use Spark, you can use various different engines for you to run this, run your workloads. In short, the key thing is we are making it easy for you to build consistent programming model where you can process your streams of data or batches of data in a single consistent environment and run it. And with Dataflow SQL, which we are announcing beta of, it allows you a few more capabilities now, like running information from GCS files and all. Just makes it more easier for you to go ahead and do that. With that, let me actually invite Rob to share more of what they're doing in Spotify, leveraging this platform. Hey, Rob.
Thanks. Thanks, Sudhir. And quick show of hands, who's familiar with Spotify? OK, I thought so. So I don't have to explain myself quite that much. So my name's Rob. I'm a product manager at Spotify responsible for data collection. And data is the foundation of almost everything we do at Spotify. For example, we'll analyze your listening habits, package together 30 songs which we think you're going to like, but you probably haven't discovered yet, put them in a 30-song playlist, and deliver it to you every Monday. That's called Discover Weekly, and it's one of Spotify's most popular features. But we use data for so much more than personalization and recommendation. If you listen to a track or a podcast, we record that so that way we can pay the artist, the label, and the other rights holders. Then we use data for business intelligence to determine what features we should build next. And we use data to run experiments on those features to figure out if they were any good. And the list goes on. At the center of all this is the event delivery infrastructure, and that's what my team is responsible for. So in 2016, Spotify was moving to the cloud. The on-premise event delivery infrastructure was processing 1.5 million events per second, and this was growing quickly. And we, as a company, had an opportunity to get to the cloud as fast as possible. So we were willing to accept some tech debt in order to make the migration path backwards compatible for data production and data consumption. By doing this, this was a great decision in 2016 as we were able to get to the cloud, but now it's having some adverse effects on our data quality, and I'll get to that in a second. So this is what the architecture looks like in 2018. So to explain a little bit about what's going on in the diagram, if you listen to a track or podcast on your mobile phone, we send that to the access point where we log the data to disk. And the fact that we log this to disk and the libraries we use to do so, this is really the tech debt that's been giving us problems. Then a process picks up the data from the access point, sends it to PubSub. The ETL process reads it from PubSub, puts it in an hourly bucket with all the other like data that was produced that hour, removes duplicates, makes it GDPR compliant, and puts it in its final resting location in cloud storage. At this point, we have an immutable data set accessible to the rest of the company. But things changed drastically from moving to cloud in 2016 to getting to this point in 2018. The big one, which swept through the industry, was GDPR. And we did design with user privacy in mind in 2016, but GDPR was an entirely different animal. We had to adapt the architecture drastically to be able to meet the new compliance needs. More interesting changes, perhaps, was just how popular Bigquery became with Spotify's data science community and the industry in general. And similarly, the popularity of consuming data in a streaming fashion, whereas we had only designed the system to support batch. So as you see at the top of the diagram there, it's almost a different event delivery infrastructure to support streaming. But possibly an even bigger change was our explosion of scale. So in 2016, the on-premise infrastructure had 1.5 million events per second. So we designed the cloud solution for 4.5, so triple. 2 years later, we far exceeded our design. So we had almost 8 million events per second in 2018. And I tend to think about data, or the size of data in events per second. But the real wow numbers is what I just pulled up this morning. 502 billion events every day. So over 500 billion events every day. And that's 350 terabytes of data produced every day. And the thing is, data increases faster than just with your number of users. As the company becomes more and more successful, you invest more and more in your data and insights community, which then increases the demand for data and therefore also the supply. So we need to make sure that we're ready for the next several years of quadratic scale increase. So late last year, we decided it was time to rebuild. We want to be ready for the scale of the future, but we also want to make sure that we're designing with 2019's tech landscape in mind. Concretely, that means we want to take advantage of the latest and greatest from Google Cloud, the latest and greatest from Spotify's core infrastructure, and design with GDPR in mind from the beginning. And the business value that we get from this is to remove the tech debt and improve Spotify's data quality to unlock lots more. So the strategy that we're taking in order to achieve this, we're redesigning the way that you produce data. So we've added SDKs for all the different ways that people use Spotify. We've changed what the data looks like on the other side. So we've updated the schemas and changed the consumption format. And we've redesigned the workflow that users use to add new data sets and to modify schemas. Once we've redesigned these interfaces, we spun up the old infrastructure behind the new interfaces and began moving some production traffic over. And we're able to do this easily largely because of the cloud. Once the code is all ready, we press some buttons, we pay some money, and now we have 2 massive event delivery systems running with production data. And while that's going on, while we move more and more production data over to the new infrastructure, which is at this point new interfaces with the old infrastructure, the real rebuild is happening under the surface. So this is where we are today, so November 2019. Because we changed the interfaces, because we wanted to double down on Kubernetes and data flow, we've had to rebuild almost all the components that we had in the 2018 infrastructure. So everything you see in a green circle there is new. Yes. You can see that streaming is still sort of an appendage there. We've managed to reduce streaming from a separate infrastructure to a data flow job, which is doing some schema transformation in GDPR. And there's more that we can do there. But this is where we're at today. And the preliminary results have been super promising. We've managed to reduce costs significantly, both in terms of actual dollars, but also in terms of operational savings. But the hidden benefit here has been that our engineers are now able to focus more on what's giving real value. So in this case, it's improving the data quality, as opposed to putting out fires that we had from the scale we didn't expect, or focusing on tech debt. So we changed the wheels of the bus while it's moving. We moved 23% of production traffic to the new infrastructure. But now it's time to try to change the engine. We've been working heavily with Google, and this is still aspirational, but we've been working heavily with Google to make this the reality. And we firmly believe that an event delivery architecture of this scale can be just a service publishing to PubSub and a data flow job, which does all the parts of the ETL and puts it in the 3 places where Spotify's data community would like to read the data. So we're doubling down on our investment in infrastructure so we can stop investing so much in infrastructure in the future. And isn't that why we're all moving to cloud in the first place? If you thought this was exciting, we've got some blog posts on Spotify Labs where you can read more. There's 3 blog posts which articulate how we moved to the cloud in the first place, as well as some war stories along the way. And then there's a blog post we published last week, which talks about the last 2 years and the experience there. And if you found this really exciting, we're hiring. Sudhir?
Thanks a lot. It's actually pretty fascinating to see the journey of once you're migrated to cloud, how you can keep modernizing the infrastructure to reduce the complexity and not carry the tech debt that you have. The other convergence that we are seeing is this hybrid and multi-cloud environment, where your data environment, which is spanning across multiple different data centers, on-prem, across multiple clouds, bringing them together is actually one of the key focus areas for us, especially with data fusions, general availability, and more importantly, ability to go ahead and bring data from on-premises systems as well as your different environments that you may have in cloud into a single place is what data fusion allows you to do. And especially with this lineage capability, you'll be able to do field-level lineage across your whole data pipelines and manage that. So it's like pretty exciting for us to go ahead and see what organizations can do with it and how they can benefit from these key capabilities. This is just a visual view of, at every field level, you should be able to go ahead and track back where the data came from, and if something goes wrong, you'll be able to figure out what was the source system for it, at what time it was updated, when did the pipelines run. So whole end-to-end audit capability on your data pipelines is what will be available to you in coming couple of weeks. With that, the another thing is we see a lot of organizations leveraging our data sets that are in our ad systems to go ahead and do better management of their spend, better return on investment based on that platform. So one of the things we are going to do is all of the ad sources that we have around from Google Cloud, ability to pull the data from ads as well as YouTube sources into BigQuery, we are going to make that absolutely free starting 1st of Jan. So it will be easier for more organizations to go ahead and collect this data, process it, and analyze it better. The fourth area, which is super critical for organizations where we are seeing convergence, is this AI and analytics. As I said earlier, organizations have a lot of challenges. And historically, the challenge was there was not enough capacity to go ahead and work on all of these problems organizations have with the talent that they had, because doing machine learning and AI was such a niche skill with very few PhD data scientists that you always had more problems than you could work on. Our goal actually is, how do we democratize solving of these problems, making it super simple for you to go ahead and work on these machine learning problems or these key problems that can be solved with better machine learning models and all. And we are enabling organizations to do that using Bigquery Ml. What is Bigquery Ml? It's literally 2 lines of code along with a SQL statement. You say create model name, and give the input data set, and say which column do you want to go ahead and predict at the end of it. And it will automatically create a machine learning model based on that. And for prediction, you can just go ahead and call select ml.predict, and then give us what you are predicting, and then give the input data set, and that's it. It's as simple as that. So you will be able to go do that with Bigquery ML. Of course, you can also use AutoML tables, which allows you to pick a table in BigQuery, pick a column that you want to predict, and we will create the machine learning model. But a lot of times, organizations want to use models that they're familiar with, the analysts may understand, and they want to go ahead and do that. And that's what Bigquery ML allows you to do. We have all the different types of models that we provide around classification models, regression models. As I said earlier, you have k-means clustering. You have recommendations from you can use matrix factorization for recommendations. A lot of marketing analysts are using the k-means clustering to do segmentation. You can take all your data set around your customer data, and you can say, hey, can you go ahead and cluster them based on different attributes, and then do better customer experiences for your organizations. So a lot of different kinds of models we are enabling. One of the key things we are also focusing on is model import-export. I think it's super important that you build a model in BigQuery. You can do some batch actions on it. Like, for example, you do better segmentation, take that input, and go ahead and do a better experience in an offline fashion. Maybe sending emails, maybe sending different kind of offers to folks. But we do believe more and more organizations will take those models and operationalize them into their front-end applications. And for that, we are basically enabling importing as well as exporting of models through TensorFlow over a period of time. So when you do that, you can create a model, you can take it out, and then actually host it in machine learning engine, ML engine, Kubeflow, and then actually start running those for serving platforms. A great example of this is Geotab. Geotab runs actually a fleet of vehicles across Canada, and they have sensors on each one of these vehicles. They're basically collecting various different temperature, speed, different sensor attributes, and then basically able to consolidate that, run machine learning models on a geospatial data at scale, and then provide interesting insights to city planners and selling that as a service now. So really innovative company that's doing this. So bringing it all home, the key thing is there is convergence happening across different kind of scenarios. And with Google Cloud, especially our smart analytics platform, what we are enabling organizations to do is not get stuck into one or another type of systems. We are building platform that allows you to converge these concepts. Whether it's data lake or data warehouse, you don't have to think about it. Yesterday Shane was saying this, you can have a data lake in the morning and data warehouse in the afternoon, and you can leverage both of them interchangeably. You just have to worry about what data you're bringing and what value you're going to get out of it, period. Similarly, stream and batch processing. I think over a period of time, most of the systems are going to be streaming based. So today, if you start building applications that are both stream and batch processing in a consistent fashion, you can absolutely move it to the next generation without having that much tech debt. And then hybrid multi-cloud environments. We are living in a hybrid environment in most cases. Making it easier to go ahead and break down the silos is one of the key areas. And then, of course, analytics, AI, machine learning is going to be a key component across the whole organizations. This is not just possible for us to do it by ourselves. We do have a huge partner ecosystem. We do know that you have invested a lot in different kind of tooling, whether it's BI tooling, whether it's ETL tooling, whether it is data integration, analysis, visualization. We work with a huge set of partner ecosystem to go ahead and make sure all of those tools are working great on top of our platform so that your investments are always protected and you're getting the best value from the whole environment. We also have a massive ecosystem of our Gsi partners, and we are working closely with them to go ahead and provide targeted solutions. For example, we are working with Accenture to go ahead and provide Accenture as well as Infosys on migration services. We're working with Wipro on some of the BI capabilities that we're going to provide. So basically, different kind of solutions across all of the different kinds of GSI partners that are there worldwide. And then finally, Looker, we announced the intent to buy Looker earlier this year. It's a great tool. A lot of our customers already go ahead and use them. They were one of our top partners in BI space already. And our whole thing is we're still pending approvals, but our whole goal will be to provide end-to-end integrated platform, starting from collection, processing, storing, analyzing, and building data applications and visualizing. So that's going to solve a key end-to-end problem. Having a common data model with their modeling layer is going to be super critical for organizations. One of the challenges I see with organizations when I talk to leaders is there's no common understanding of metrics within organizations. If you go ask what the cost of goods is or margin definition is in different departments, you get different answers. And so providing a common semantic modeling layer is going to help a lot for organizations. Augmented analytics, we have this theme around AI-powered BI. So we want to go ahead and invest in that and make it available. And then, of course, industry applications. So we have end-to-end solutions for our customers is going to be key focus area. Other than that, I do want to mention we have made a lot of progress in last 3 years or so. When I joined Google 2 years back, I think we were in mostly challenger or different in quadrants and all, challenger and visionary and all of that. But in last 1 year, we have been in leader quadrant or leader in every one of the waves that has come out around analytics. And whether it's DMSA, whether it's Forrester's cloud data warehousing wave, or the recent one, which is streaming analytics wave, which is our debut. Like, this is the first time we just were invited to it, and we directly launched into the leader space in that. So super excited about the recognition we are getting. Finally, I want to thank you all for coming here. I know it is almost afternoon time, so thanks for joining us. And please do give us feedback through the feedback application. Thank you.